Welcome to my channel, I'm HaKDMoDz. In this tutorial you will learn how to hardwire a microcontroller with a Bluetooth module. Then we will develop code required to perform the task of controlling a few LEDs. Things you will need: an Android mobile phone, a HC06 Bluetooth module, Arduino Uno or a Nano, jumper wires, one breadboard and a few LEDs. In this video we will learn how to control LEDs. In the next video we will learn how to alter the project to control any electronic device that you wish to control remotely from your Android app. An Arduino Uno 328 is what we'll be using for the process the functions that we will develop in our program. Next you will learn the coding process which works with the Arduino and get a feel for what is required from our program to run smoothly. After which we will create an Android mobile or tablet application for sending the remote commands over a serial port that we have created using a Bluetooth module and the serial port remote protocol. We first have to write a binary program and store it in the bootloader section of the microcontroller, which has a 32 kilobit memory allocation, of which 500 bytes is contained by the bootloader. The Uno we will be using is a 328. It has 14 digital I/O pins, of which 6 can be used as pulse width modulation outputs, 6 analog inputs. Also it has SDA and SCL pins and a reset pin. It is programmed by the Arduino Uno IDE. A microcontroller such as the one we will be using, which is the Arduino Uno 328, is a shift resistor clocking device of sorts, which understands only high and low voltage signals, which we open and close electronic gates inside the controller. After developing the bootloader program, the Uno will then learn how and what functions we wish to perform, at what intervals and the system clock runs at, and what to do when the executable commands is received via Bluetooth serial port. The Atmel 328 8-bit AVR RSC-based microcontroller combines 32 kilobits ISP flash memory with read-while-write capabilities, 1 kilobyte EEPROM, 2 kilobytes synchronized RAM, 23 general-purpose I/O lines, 32 general-purpose working registers, 3 flexible timer counters with compare modes, internal and external interrupts, serial programmer USART, and byte-orientated 2-wire interfaces, SPI serial port, 6-channel I/O bit AD converters and an internal oscillator, and 5 software selectable power saving modes. The device operates between 1.8 and 5.5 volts. The device achieves throughput approaching 1 megs per second per megahertz. Download Fritzing from fritzing.org/downloads. I will speed this process up to minimize video time. So once the video is downloaded, you'll receive an archive with Fritzing application inside it. I'll just wait for the download to complete. Once that's downloaded, you'll need to extract the archive and store it in your program files folder on your C drive. If you already have Fritzing installed, skip this process. Okay, now extract the program file folder into your C/program folders. If you're on a 32-bit machine, you'll extract it to C/program files. If you're on a 64-bit machine, you'll extract it to C/program files x86. Then run the executable Fritzing inside that folder that you've just created. This is what we'll use to create our sketch. So let's get into coding our program known as a sketch, which will be flashed to the bootloader. we must first declare which pins we are using and assign a type and variable name to each declared pin. So we'll be using integer of type, and light 1, light 2, light 3 will be set to pin number 2, 3 and 4 of the digital I/O pins. We'll also be using an integer of type, and not connected will be the variable name, and we'll be adding it to pin 5. Int connected will be pin 6. Now that we have declared our pins, we next need to add our setup and loop function. In the setup function, we will initialize our pins as outputs and tell the serial monitor that we're using a baud rate of 9600. We do this by serial.begin, and inside the brackets we put the baud rate 9600. Now we need to initialize each pin as outputs and set their value to low for all pins except not connected, so that when the device powers up, not connected will be set to high, which means the LED will be powered up for only not connected. So when we connect, it will go off and connected will light up. So we'll be declaring pin mode for light 1, 2, 3, 4, 3, not connected and connected as outputs of the digital I/O pin allocations. We'll just copy that line because we've got 5 of them to do. So copy and paste, Control C, Control V. Change the variable name for the same one as you have at the top. Not connected. Once more for connected. Now we'll tell the setup function that each pin is output. We've done that. So now we need to set each pin to low except for not connected, as I stated a second ago. Quickly neaten up our code. Okay, now we're into the loop section. The loop section is what will reoccur. And we'll be using some if statements along with case statements, switch case statements. So if serial.available, which is a method, greater than 0, which means if serial is available, then do this inside the brackets. We need to initialize a data, a char variable of type, and data is the variable name, and it will be listing on serial.read method. So any command that we send through the Bluetooth will be heard by serial.read, and it'll do these functions based on what we declare. So we'll set up a switch case statement and tell it will pass data as the input. So if data contains A as the case, then we will light up light 1. Note that it's a capital A as the first case. Second case will be lowercase a. So A capital is on, A little is off. B capital is on, B little is off. You get the point? Okay, now we'll add a few more so that we can know whether the program is connected or not connected with a Y and an N. We'll also do an X and a lowercase x. Okay, so now we've set up our cases. Now we'll define what each case is capable of. Okay, so case A, digital write, light 1 high, and set serial print line to light 1 is on. Close the statement with break. Copy and paste that, except for the case part of the sentence method. Sorry. Now we will copy and paste that to each case and change a few things within. So it's, as we said, light 1 will be high, little a will be low, so we'll change it to low and light 1 off. This next one will be light 2 and it'll be set to high. Light 2 is on. Number 3 will be light 2 low, light 2 is off. C will be digital write, light 3 high, serial print line, light 3 is on. Same for number C, little c. So digital write, light 3 low, serial print line, light 3 is off. Okay, so next one will be Y, digital write connected equals high, serial print line, Bluetooth connection successful. So if we send it a Y of the character Y, it'll be heard into the data type of char, and it will be stored and heard by the switch case statement that has been passed it, and it'll turn the Y LED on. So we'll add a serial print statement saying connection successful and finish that statement with break. That line seems to have got chopped off. I'll zoom out at the end of the code. So next we'll do digital write. Connected equals low. Or not equals, but set to low. Digital write not connected set to high. So it's one or the other. Not connected means that the light will be on and connected light will be off. Same way and vice versa. So always good to add serial print lines to end of each task, so that you know where you're going for debugging. So if it gets to there and it fails from there, then you know where you need to go to. But this won't fail. It's only if you're still learning. Okay, so case X, light 1, we'll make case X turn all lights on, and lowercase x turn all lights off. So digital right, light 1 high, digital right, light 2 high, digital right, light 3 high, and we'll give it a serial output of all lights are on. Finish the case with break. Copy that, paste it into the lowercase x case. Just change it all the highs for lows. And change the output statement as all lights are off. Finish it with break. So low for light 3, low for light 2, low for light 1. And we'll make it output what it received from data when it is received. Just neaten up the code. And we'll set a delay of 50 milliseconds between each listening clock connection. Okay, we'll add a few blank lines. And we'll add a waiting for connection statement so that you can tell what the program is doing at the time. We'll add another blank line underneath that so it doesn't all get conglomerated. We'll add blank line statements to the end of each case. So copy and C, Control C, sorry, put before break on each line so that it adds a new line to the end of the read and output to your serial monitor. Okay, so now we'll save that. So that concludes the code section of the project. Now we'll draw a diagram and an overview schematic blueprint of the wiring of the hardware so that we know what we're doing exactly before we get into the hardware wiring. Okay, so in the breadboard tab on Fritzing, drag out a few LEDs. We'll just grab all the components that we require. which are the breadboard, the LEDs, the HC06 module, the Arduino Uno. Okay, so just colour them. One's green, one's blue for not connected and connected. I'll just leave the 3 yellow. Okay, drag out your HC06 Bluetooth module. I'll rotate it. If you're following along, just copy along as I'm going. We'll try and keep it as compact as possible. Okay, next the breadboard. We'll swap it out for a bigger breadboard. We're using the properties on the right. Drag it into place. Okay, now we'll start putting LEDs onto the board. The left leg is the positive leg, the long leg, the one that's not bent. The one that is bent is the negative. They're called anode and cathode. The way the LEDs work is the positive power pulses up the anode, vibrates between the anode and the cathode as it dissipates through the negative, and that causes illumination of the LED. Okay, so now we've got the HC06 module in place. We need to draw the VCC line to the red power rail of the breadboard. We also need to draw the ground black wire to the negative rail of the breadboard. Then we'll draw a wire from the TX to the RX, pin 0 of the Arduino Uno. Remember, try and keep it as compact as possible. And try not to overlap too many wires. Try not to overlap any, in fact. Intersections are okay, but overlapping wires make it difficult for PCB manufacturing. Okay, now draw the TX line, which is pin 1, and it'll go to the RX line on the HC06 Bluetooth module. So remember, this Bluetooth module TX goes to RX on the Uno, and RX goes to TX on the Uno. As you can see, I've done here. That's why we draw a schematic over blueprint to work out what we're doing first before we go and possibly corrupt the hardware. Okay, we'll colour them lines, yellow and blue, and we'll colour the negative line black, red for the positive. Okay, so that's the Bluetooth module done. Okay, so now we'll power up one of the LEDs from pin 2, as we stated in our code. Pin 2 is LED light 1. So that's to the power line on the LED. I'll move these LEDs in a second. I'll just get these wires right. Okay, so that's pin 2 to LED positive 1. Now we've got Arduino Uno digital I/O pin 3, which will go to LED number 2, light 2, which in the next part of the project in the next tutorial will be device 2. As I stated before, this is just to show how to control LEDs, but in the next tutorial I'll change it out for electronic devices. Okay, so now digital pin 4 will come to LED number light 3. Try not to keep them running across each other. Intersection is okay. Okay, so now we need the connected and not connected. We'll just colour those wires white. Helps to try and keep uniform the colours that you use in the hardware when you physically wire it up as to the schematic, so that you don't get too confused. Okay, so digital pin 5 goes to the connected LED. We'll just bend that anode. Okay, move this up a little bit so we can actually get pin 6 in there. Okay, so pin 5 goes to connected LED, pin 6 goes to not connected LED, which is the blue one. Okay, that's fairly neat. Okay, now we need to power the breadboard via the 5-volt rail from the Arduino Uno to the 5-volt rail on the breadboard. That provides power to the HC06 module, and it'll present ground for the LEDs as well as the HC06 module. Okay, so from the 5-volt pin, on the Uno, drag a line to the 5-volt rail. So that powers up that red rail along the breadboard. Now we need a ground. Okay, so that's the ground. We'll make it black. And we'll try and get it as neat as possible. Okay, so that's black. So now the positive and the negative power from the Arduino Uno is powering the breadboard in turn, which powers the HC06 Bluetooth module, which also gives grounding for the LEDs. Now we just need to ground the LEDs. This code and the sketch blueprint can be downloaded from that address just shown. Okay, so that's the breadboard sketch. Now I need to put the LEDs negatives to the negative rail on the breadboard. So for each bent leg of the LEDs, draw a black line to the negative rail. This almost concludes the schematic overview. There's also a diagram there of the exact wiring. Okay, so that concludes the schematic blueprint creation using Fritzing. So now we'll get into the hardware and the wiring. So you need your Arduino Uno. I'm using the 328. Okay, so we'll make sure we've got a charger compatible. It needs to be no greater than 12 volts and no less than 5 volts. 7 to 12 is good. Okay, so you'll need your components now that we've previously detailed. Okay, so you've got HC06 Bluetooth module, or even a HC05 Bluetooth module will be okay. The breadboard, I'm using the Mini Plus breadboard with power rails parallel. Okay, you'll need your LEDs, 1 blue, 1 green and 3 yellows as per the schematic. Plus you'll also need 2 toggle switches or tactile buttons. We'll come back to the tactile switches later. For now we'll just wire the Arduino with the Bluetooth module and the LEDs. Then I'll explain why we need the tactile buttons or switches. Okay, you'll need your jumper wires. These are just male jumper wires. Put them to the side. Okay, so with the HC06 Bluetooth module inserted into the breadboard, now we'll follow the VCC line, which is 5 volts, and we'll put a jumper wire, preferably a color orientated wire, for example yellow or red or orange to indicate power, and we'll plug that into the 5 volt rail of the breadboard. That's on the VCC line of the HC06 or 5 Bluetooth module. Okay, now we'll need a ground, so a black, a blue or a green wire. Doesn't matter, but it's optimum to keep them all uniform. I'll be using a green wire. Green for earth, so that's the ground, GND on the back of the Bluetooth module. So follow the ground line, it's mark GND and put a pin into that, as well as the negative rail of the breadboard. And then I'll go into the blue rail of the breadboard. Yours may be black. That gives power and earthing to the HC06 Bluetooth module. Now we need transmission lines for the HC06 Bluetooth module to the Arduino so they can communicate. Okay, now this is important. On the back of the HC06 Bluetooth module there's a TX and an RX. The TX of the Bluetooth module will go to the RX of the Arduino Uno. So plug that into the TX. And plug the other wire into the RX. Okay, so now follow the TX one from the Bluetooth module and it'll go into the RX, which is pin 0. Okay, so this is the RX on the HC06, so it'll go into TX, which is pin 1. There's 13 digital IOs. We'll be using 7 of them. Okay, so the TX will go into the RX, and the RX will go into the TX. So that one I just plugged in was RX on the Bluetooth module, and it goes into pin 1 of the Uno, into the TX pin. And this next one is the TX, and it goes into the RX pin of the Uno, which is the pin 0. So 0 and 1 are full now. and they're communicating with the Bluetooth module, which isn't powered up yet, but we'll get to that soon. Okay, so now 5 volts. We'll go into the 5 volt rail of the breadboard from the 5 volt output of the Arduino Uno. That'll power the breadboard. Now we need a grounding. So again, use the green, blue or a black and put that into GND, ground, from the Uno to the breadboard's negative rail. Now you'll see that the Bluetooth module is powered up. Okay, so the negative is the short wire, short pin on the LED. So the long wire is the positive, which will transfer signal from the Arduino Uno via the digital I/O pins. So keep them all the same. It's best to put the positive, which is the long leg of the LED, to the left on each pin on each LED that we plug in, so you don't get confused. So long leg to the left. So that's connected and not connected LEDs plugged in now. Now we'll put in the 3 light LEDs, which in the next tutorial will be devices that we're controlling. And the last LED, remember to keep the long leg to the left. Remember, we're sticking to the schematic, so if you need to have a look at the schematic to follow along, do that, print it out and follow along or something. Or you can just continue to watch and follow along that way. Okay, so I've got 5 jumper wires of the same colour, so that I don't get confused and so that I don't confuse you. So I'll just move these around and use the same negative pin. Okay, so I rotated the pins on the LED, sorry. Now I'm using a common ground for the green and the blue LED, so which means that the short leg of each green and blue LED are on the same line, so that we only have to add 1 wire for 1 grounding, which will ground both LEDs. Same as the yellow. Keep all the short pins on the same line. So now we put a grounding wire from the negative rail of the breadboard to the blue. We'll go for the yellow first. Put it in the same line as your 3 short legs from the LEDs. Okay, so now we'll test with the 3 volt output of the Uno, and we'll test each LED by putting it on the pin line of each LED. So that's 1, put on the next pin line, that's 2, put on the next pin line, that's 3. If you can see that. Okay, so they are all working LEDs. Okay, so now we'll remove the 3 volt line. That was just to test the LEDs. Okay, so we'll put that on the first pin line, and that'll go to digital I/O 2, as we stated in the sketch and in the diagram. So now the Arduino Uno, because of the code that we haven't flashed yet, we'll flash that soon. So now once we flash that code to the bootloader in the ROM, then it'll know that the pin 2, pin 3 and pin 4 are yellow LEDs. Okay, so we'll put the second jumper wire onto the second LED positive long leg, and we'll put the third LED long leg pin jumper wire to the Uno. So now you should have 3 wires going to 3 different LEDs, and the short leg of each LED should be on the same row with a negative going to the negative grounding line on the breadboard. Okay, so now we'll do the same for the blue LED, which is not connected, sorry, as in the code, and 1 to the okay, so we'll just test these LEDs. So 3 volt, that's fine. So now we'll plug that into the digital pin 1, 2, 3, 4, pin 5. Okay, now the connected LED, which is the green one, which will notify us that we're connected via Bluetooth. We've tested that now with the 3 volts. Okay, so now we'll put that into pin 6. So now you should have 3 LEDs, all with one common grounding, and 2 green and blue LED with the same common grounding into pin 4, into 5 and 6. And you should have TX and RX going to the Bluetooth module and into the RX of the Uno, and the TX into the RX of the Uno. Okay, so you should have them twisted. The TX into the RX into the TX. I'll change that for a different one. Okay, so I've just removed the TX line from the Uno, and I'm just adding a longer line, a longer jumper, sorry. And it's not white, that way we don't get confused. Okay, so that'll go into the RX pin of the Uno, of the HC06 Bluetooth module. So it can either go into the back of the pinning, or it can go into the front, depending on how you've got it set up. Okay, so I'll put it into the front to show that it works that way as well. Okay, so now we'll compile the code that we previously wrote in Fritzing, but now we'll use the Arduino IDE. Okay, so open up the Arduino IDE. Link will be in the description if you haven't already installed Arduino IDE. Okay, so now we'll push compile with our loaded sketch, and you get 2 errors. It'll say which line numbers, but I'll make it easy, and you just got to change the print statement to print line. Print is not a variable, not a valued command for this. So once you've changed them 2 print statements to print line, you'll have no errors, and it'll compile fine. Okay, so now we're going to plug the Arduino Uno into the computer for flashing. You'll need to be using Windows or have Linux set up correctly to compile and execute the code into the bootloader. Okay, so plug the USB into the Uno and the other end into their laptop or computer. You get a sound notification to say the Uno has been plugged in. Okay, now to pick the COM port, what we need to do is right click the Windows logo, go to Device Manager, go to Ports, find the COM port with the Uno plugged into it. Mine's COM 6. Now go to the Arduino IDE and find the port COM 6. Make sure the baud rate's set to 9600 and you're on Arduino Uno with an AVR ISP Mark II programmer. Auto format the code, save the code, fix the encoding and flash. That's converting it to binary, which gets stored in the bootloader of the Uno. Okay, so this is where we need the toggle switches. So you'll get an error. That's because we're using the read-write line of the Uno, which is pin 0 and pin 1. They're being occupied by the HC06 Bluetooth modules transfer and receive. So to fix this, what we'll need to do is get a toggle switch, put it into the breadboard. I find toggle switches the easiest. You can just remove the wire while you're flashing, but a toggle switch makes it more neat. So plug 2 toggle switches in. One will be to cut the Bluetooth transmit and receive line, and the other one, the other one will be the receive line. So the TX line from the Uno, the RX line is the blue one, the TX line is the yellow one. So remove the TX line, the RX line, sorry. I mean to confuse you. Pin 0, remove it from the Bluetooth module. Plug the wire into the same hole, and from one side of the switch on the pin that is common, and plug the other wire remove that wire now. So plug that wire into pin 1 and it goes through the switch, and on the other side of the switch in the other pin it will go back into the Bluetooth module. So now when you hit the switch, it'll disable the Bluetooth TX line. Okay, now we'll do the same for the RX line. So remove the pin 0, put it to one side of the switch, put the other pin on the other side of the switch, or toggle button, back into pin 0. So now if we hit the switch, it'll disable pin 0 and pin 1, and we'll be able to flash the Uno with the bootloader's binary code. Okay. Now that's done, we'll compile it again and reflash. So push the flash button to the Uno. That's converted it to binary when we compiled it. Now it's flashing it to the bootloader section of the ROM in the 328. Okay, so that's flashed now. you'll know it's flashed because the lights will indicate on the Uno, as well as the blue not connected LED should now illuminate, because that's what we've told our code. If serial connection is available, illuminate blue. Okay, so now we'll turn our buttons, switches back to enabling the Bluetooth module. Okay, so now you've wired it, you've flashed it. Now, with the Arduino Uno, hit the serial monitor on the top right hand side, and your script should start running the program sent by the Arduino. Okay, now that you've verified that the code has been compiled and uploaded to the bootloader, we'll open Chrome or any web browser, and in your search term, type MIT App Inventor. The link will also be in the description. Okay, so we'll select MIT App Inventor. You may have it as a bookmark already. You'll need a Google account for this. If you haven't got one, create one. So log into your App Inventor account, and we'll create a new project. To create a new project, go to Projects and go Create New. Label it appropriately. Okay, now so we'll drag out some layout components. First we'll do 4 horizontal layout arrangements, and we'll set the width to parent. Label each component. You can leave most of the default properties as already set. We'll just adjust the width after we finish labeling them. So we'll set the fill parent for all 4 of the components. Okay, now that we've done that, we'll drag it. We'll go to user interface. Actually, first we'll put another component, another horizontal arrangement component inside the top one. We'll put 2, and we'll set them both to 50%, so they halve the distance. That might be a bit much, you won't see the border, so we'll go 48% on each. That way you get a margin of 2. That looks okay. Now we'll go to user interface, and we'll drag out a list picker component as well as a button. Okay, we'll go down, we'll put text on the button, on the list picker. We'll call it Bluetooth. This will be the Bluetooth button that we can select our elements from the Bluetooth addresses that are available. Okay, so we'll make a second button, the actual button on the right hand side, we'll make that a disconnect button. Set the backgrounds to black, whatever color structure you like. Set the text to centered. Set them both to fill parent. Okay, now we'll drag out a label, put that into the second layout, horizontal layout. This will be our succession status label. We might put a horizontal arrangement in first, or a table arrangement, even better. Set it to fill parent. Now into the first row, our first column of the table arrangement, we'll place a horizontal arrangement. And we'll put another one in the second column. Set them to fill parent. We'll drop another one into the bottom row. Set the percentage to that, and it's the same again for the top other one. Okay, so we'll drop our label into the first one and our second label into the second one. This will be a success label. Successful connection. And we'll name it success. I will input the text successful. Okay, we'll name the other one unsuccessful. Okay, we'll center the text. Set them to fill parent. Label 2 container. Okay, we'll set the background to black. Set the text color and size to 18. Make it HTML format for both of them. Set the text color to white. Adjust the view width percentage. Okay, we'll drag out an image for the center of the screen. Pick an image of some kind. I'm going to use a GIF animation. So you need to upload the image and set it as the property. We'll need to adjust the size scale to fit. And we'll set the parent height, the child height to fill parent, and the width also to fill parent. That'll bring the image central. Set the screen background to black. Set the list picker and the button container to black background. Set the animation for the opening screen to zoom. Set an icon, has to be a bitmap or a JPEG. Set it the size screen scaling to responsive. Give the title for the screen. Okay, now we need some buttons. First we'll get another horizontal table arrangement so that we can put our buttons into each column and each row. We'll name the table button container. Name the table button table. Set the central vertically and horizontally. Set the background to black. Or blue even. Set the number of columns to, we'll go 8 columns and 2 rows. Okay, so we'll start dropping some button components now into the columns. Set the background to a different color so we can see where we're working. Okay, drop in 6 buttons. Okay, so start labeling the buttons. Okay, this will be light 1 on button. Next one will be light 2 on button. Next one will be light 3 on button. Next one down will be light 1 off button. Next one will be light 2 off button. The last one will be light 3 off button. Okay, now we'll input the text. For the first button, it'll be light 1 on, or we'll just put on. Same for all the top row. The bottom row will be off. We might make them light 1 on, light 2 on, light 3 on, light 4 on. Oh, sorry, light 3 off, light 2 off, and light 1 off. So this row will be light 1 off, light 2 off, light 3 off. Okay, I'll set the text to white. Font color white. Now we'll change the button color to red for for off, green for on, so we might make the background black, the text black, sorry, and text black. Actually, we might make it green, sorry, and black for the background. That looks better. We'll do the same for all three of the top row. So black text, black background, green text, lime text. For the bottom row, we'll make it black with red writing. So set the background to black. Change the style, the writing font style. Okay, last one, black and red. Set this font style again. Change the background of the button container. Okay, so we'll delete the text on the success label, as well as deleting the text on the unsuccessful label. So now we'll need some Bluetooth client component, and a clock component. Okay, now we'll go to the blocks design. Okay, so when screen 1 initialize, we'll just drag up some of the components that we'll need. So after list picker has been chosen and before list picker has been chosen, to select the component for each item, click on the item and then it will give you a list of available options. Okay, so we'll also need disconnect button when on click event. We'll also need a set connection label text to successful. Okay. We'll also need a Bluetooth Connect address component and a call Bluetooth disconnect method. As well as a call Bluetooth send text. And a Bluetooth is connected. So we need to send text. So we'll also need a Bluetooth client, addresses and names component, and a few if-thens. You get them from control. So when list picker before picking, if Bluetooth client available, now we'll use our list picker, set list picker elements to selection, to Bluetooth client and addresses. So now what we've said is when list picker before picking, gather the elements that will fill and populate the list picker with items that are available as Bluetooth connections. Then we want to set the connection status label to successful. Oh, sorry, that's after picking. So we'll copy that and paste that into after picking. Okay, so now set the connection status label text to, move that up. No, we don't. There it is. Okay, so it's when list picker after picking, call Bluetooth client address. Address will be list picker dot elements, or list picker selection, sorry. So once you've picked what device you want to connect to, then what are we going to do? What we want to do is change the status label to successful. So successful equals connected. So we've got when list picker after picking, if Bluetooth client address listpicker.selection, then listpicker elements to Bluetooth client addresses and names. Then we'll call Bluetooth client send text, and we'll send it a little Y to notify the blue LED that a connection has been made. After that, we'll also set the text label to connected, the connection status label. Okay, so now we'll rejig these just to get them in place so we can work out the function procedure that's running through. Okay, so we've got when list picker before list picking, if then else, if Bluetooth client is available, set list picker elements to Bluetooth client addresses and names, then we'll need a label, a notifier, we'll use a notifier. Okay, so now we'll go down to notifier and we'll use the available options from it. So we want show alert. So we've got else call notifier send text, send a notice alert, and then we'll put a text block in there and say please connect Bluetooth first. Bluetooth enable first. Enable Bluetooth first. Okay, so now I might change this one a bit. And copy and duplicate that. So I'll make that a capital X, so that which will turn all three of the LEDs on, as we've written the code in the Arduino. Remembering that the letters that we select in the send text method need to correspond to the Arduino's function listeners. Okay, so now we'll set clock 1 timer enabled to true. Now we'll need to fire the clock method. So we'll go to the clock and we'll go to when clock 1 timer ticks, and then we'll need to disable the clock so that it doesn't run in a continuous loop. So set that to false. And we'll also need a send text from the Bluetooth client. Okay, and we'll make that a little X as per the code. Okay, we'll set the duration to 2000, which is 2 seconds. Okay, so that's pretty much got that part of the section. Now I'll need to start doing some button click events. Okay, we'll do the disconnect button as well. We'll need a new method there. Zoom out a little bit. To zoom out, hold control and roll your mouse. Just to zoom in, same thing, hold your control button and roll up. I'll delete that block. Don't know why I grabbed it out. Must have been thinking something at the time. Okay, next we'll work on the disconnect button function. So when disconnect button click, call Bluetooth client send text little X, which will turn all the lights off, and little N, which will alert the notification status light, which was the green LED or the blue LED. I can't remember now. I think it was the green one. Yeah, green one. Okay, and we'll set the text on the label, connection status label, to disconnected. Okay, now we need the button click event methods. So light one button click, we'll drag that out. We'll copy that 6 times and paste it with Control C and Control V. So once you've got 6 of them, we'll need to change the method to light 1 on, light 1 off, light 2 on, light 2 off, light 3 on, light 3 off. So light 2 on, light 2 off, light 3 on, light 3 off. That creates 6 methods, 2 for each button. 2 for each LED. 1 on, 1 off. True and false. 0 and 1. Okay, so we'll copy this if method, if statement. We'll drag these across out of the way. Okay, so change that method. That statement is connected. So if Bluetooth client 1 is connected, and then we'll call the Bluetooth client send text method, and we'll send text we'll send text A to turn light 1 on, capital A that is. Remembering capital A is on for light 1, lowercase a is light 1 off. So we'll pretty much just copy and paste these once we get them in place. So that's called Bluetooth client send text, text equals A capital, else we'll need a notifier. So copy the notifier since we've previously used it. So call notifier 1 send text, text equals enable Bluetooth. I'll connect Bluetooth first. I'll set that to it. Please connect Bluetooth. That's if if Bluetooth connection hasn't been established, then the function won't be able to run. That's why we have the lower else case. But above that we have the if then. So if it is connected, then send text through the Bluetooth client send text method, capital A, and we'll set light 1 status to on. We'll drag a text label out and we'll set it to light 1 on. Okay, so that pretty much covers that. Now we need to just copy and paste that and change the variables. So Control C, Control V, drag that into light 2 function. Okay, now we need to okay, so we'll change it to lowercase a to turn light 1 off. Okay, and we'll Control V it again into light 2 on. So Control C, Control V into light 2. Paste that. Now we'll just change it to a capital B and light 2 on. Same again, Control V to paste, and then stick it in the method. Change it to a lowercase b to change light 2 off, and change the status label to light 2 off. Same again, go up, drag light 2 off. Oh no, sorry, light 3 on. Copy Control V to paste, stick it to the method, change it to a capital C, and change it to light 3 on for the label. So this will be on. The other one was a lowercase c, so out of alignment. Okay, so that's pretty much got the button click methods. Delete the 2 methods here. Okay, so we've got now the button method click events under control. We've got the before list picker, after list picker. I might delete that, just say enable Bluetooth. So the after list picker now, just go through each method and verify they're done correctly. Okay, now we just need to add a procedure, and nearly done. So go up to the procedure, drag that on, and you want to copy the disconnect method. Drag the blocks out of the disconnect method. And then call the method from the backclick event. Whatever you label the method in the procedure, you have to label the backclick method call event. Okay, so that concludes the Android app development. I might just change this image because it doesn't spin for some reason on Androids. So I'll just change it to a LED lamp. Okay, so now we need to build the app, so go up to build and save APK to computer. Okay, that'll save it to a location. Give it a name. I'll call my Bluetooth Arduino Droid. Save. That'll download it. Show it in folder. Now my Bluetooth on my phone's already on, so I'm going to send it to Bluetooth. Okay, hope this helped. Now you know how to build an Arduino Bluetooth Android controlling device. In the next lesson we'll turn it into electronic devices rather than just using LEDs. Okay, so now that's been downloaded through the Bluetooth. Now install it into your phone. You'll need to go into your Bluetooth settings, and the password to pair with the HC05 or 6 module is 1234. Hit enter. Okay. Okay, now that's paired with the Bluetooth device. If it doesn't pair, you've got the TX and the RX wires incorrectly, or the switches aren't on. Okay, so now hit Bluetooth to actually connect to the device. So pick the HC05 or 6 module. You should see all the LEDs light up and then turn off, as well as the notification status light switch to blue from green. Now you can hit any of the buttons, the LED will turn on or off. Okay, so we'll disconnect again to show the not connected status light. Now we'll reconnect. You'll see that the light switches to blue and the green one goes off, as well as the LEDs illuminate and then go off. That's a LED test. So one more time, on off, on off.